Hello, welcome to what I'm calling part two of the 9.7 notes, which is solving for side lengths with trigonometry. We're going to start off with just making sure our calculators or other devices are calibrated and just give a quick review on rounding to make sure everybody's on the same page here. So we're going to plug these values into our calculator. So if you don't have a scientific or graphing calculator in front of you and you want to use one, go grab it. I'm going to be using Desmos in my example because it is readily available to everyone. But you can certainly use some kind of a scientific or graphing calculator if you prefer. We're going to actually be using those buttons that you've seen for so many years and maybe never have gone to use before that are sine, cosine, and tangent. So first thing first, we need to make sure that all of our devices or websites are in the same mode. So there's two common modes when dealing with right triangles and trigonometry, and there is either degrees or radians. Now, radians probably sounds unfamiliar because you've never worked with them yet. When you go on into your next math class, it's very likely that you'll get into the discussion on what is a radian. Today, we'll be dealing with only degrees. So this very first problem right here, I have the sine of 30 degrees. On whatever device you're going to use, I need you to punch in the sine of 30 degrees. I'm going to be using Desmos. When I type in the sine of 30, I know that that's the wrong answer because I've been doing this a long time. I'm going to show you how to change it. All right. Over on the right-hand side, you're going to see this little graph setting, this little wrench. I'm going to click it. And on the very bottom, you'll see a green highlight on radians. I need my answers in degrees. When I want to check that my answer's in degrees, I use this exact problem, sine of 30. And I know that the sine of 30 has to be 0.5, and that's a way that I can check to make sure that I'm in degrees. So the answer here is 0.5. If your calculator or other device is telling you that it is some negative 0.8 number, right, or anything other than 0.5, pause this video, change it to degrees. If you don't know how to change it to degrees, Google your model number of your device and how to change to degrees. And there should come up with some tutorial videos or some step-by-step instructions. Okay, so I'm going to take this 0.5 and I'm going to write it in right here. Now I've got sine of 30 is equal to 0.5. In the directions here, it says round to 3 decimal places. I don't have 3 decimal places here, so I'm not going to fill it in with zeros. I'm just going to leave it at 0.5. Okay, so for the cosine of 30. Go back to Desmos again. And now the cosine of 30. So I can do a couple of things. I could delete that. I could type over it. I could just start a new one. Cos 30. And that gives me a irrational number. 0.8662025403784. And it'll keep going on forever and ever and ever. Depending on the calculator you have, you may have the same amount of decimal places or fewer or more. I'm going to copy down about 4 or 5 decimal places when I'm transferring this to my notebook, because then I'm going to round to 3 decimal places. So if I write down 5 decimal places from that calculation, 0.86602. Now, when I am looking to round to 3 decimal places, right? Here's 1, 2, 3. I'm going to look at the fourth number. If the fourth number is 5 or greater, then I round up. If it is less than 5, then I just cut it off. So 0 is definitely less than 5, so I'm just going to cut it off, and this is going to become 0.866. 3 decimal places. Okay, so for the tangent of 30, I'm going to go back to decimals and do the same thing. Once you've changed your mode once over to degrees, it will most likely stay that. There are some calculators who every time you turn it on, you'll have to change it, but you'll get used to whatever you're using. Like if you close this window and you open up decimals again, you'll have to go to the wrench and change it again. So make sure you're always checking. Again, a good way to check is to just always plug in the sign of 30, make sure you get a half. If you want to write that down, it might be a good tip. So the tangent of 30 here, I'm going to copy down 0.57735. I want 3 decimal places, so I'm looking at the 4th decimal place, 3. If this is 5 or higher, I round up. It's not, so I just cut it off. 0.577. Those are my answers. So in this first part here, just really an exercise in finding and using sine, cosine, and tangent and making sure we can all round. Great. So please go ahead and pause this video, give yourself a minute or two, and plug in for the sine of 71, the cosine of 71, and the tangent of 71 degrees. When you plug these in, there's no need to put a degree button because you're in degree mode, so it's automatically assumed. You don't need to input like any kind of a degree symbol, right? You just input any kind of a degree symbol. You just input sine of 71. So I plugged in my sine, cosine, and tangent for 71 here. You'll see that those numbers changed. I've copied them down onto here, and now let's make sure that we're all good on the rounding. So 1, 2, 3, I look at the 4th decimal place. This is 5 or greater, yes. So I have to round up, 0.946. Cosine of 71, I count 1, 2, 3 decimal places. Here's another one. The 4th decimal place is a 5 or greater again. So I have to round up again, 0.326. When doing this, if you were to enter in 0.325 and didn't round correctly, it would be marked wrong. If you entered in 0.3255 and you didn't round to the right decimal point, that would be wrong. So this is very, very specific. The tangent of 71, 1, 2, 3, let's see. So I'm looking at the 4th decimal place. 2 is smaller than 5, so I'm just going to cut it off. 2.904. Cool. So the next type of problem is going to pull in how to set up the trig function, sine, cosine, and tangent, actually setting it up, solving, and plugging in calculator. So it's going to incorporate a lot of pieces here. I've got the steps written out for you right here. They're over here in red. And we're going to go by piece to each one of these. Example 1. Find the side indicated with a variable round to the nearest tenth. Step 1. Start from your angle theta. The angle theta, remember, is always your acute angle. So I've got 2 acute angles in triangle A. I have this one on the bottom left and this one on the bottom right. Just go to the one that they already give you the degrees for. I'm going to start here. I'm going to write my theta. Identify where your missing side and known side are. So what I'm looking for here is what information do I have that is opposite, adjacent, or hypotenuse. So what do I know? 19. Is 19 hypotenuse, opposite, or adjacent? It's opposite. What am I looking for? The x. Is x hypotenuse, opposite, or adjacent? Hypotenuse. So now using what we know about our trig functions and using SOHCAHTOA to help us, remember SOHCAHTOA stands for the sine function is equal to the opposite leg divided by the hypotenuse. The cosine function is equal to the adjacent divided by the hypotenuse. The tangent function is equal to the opposite divided by the adjacent. Problem A, I have the opposite and the hypotenuse. Which function uses opposite and hypotenuse? Sine. So here we go, I set it up. Sine of my angle. My angle is 40 degrees. Make sure you actually put the degrees in there and not theta. Theta just tells me like where my angle of reference. Sine of 40 degrees is equal to the opposite, in this case is 19, divided by the hypotenuse, in this case is x. The setup is really half the battle here. So it's the very first thing I want to make sure that you absolutely understand where I got that from. Even if you can't do it on your own yet, we're going to do quite a few of these together. The repetition will help. But make sure you understand why I wrote it the way I did. Okay, now I am going to solve. I have a number equals a fraction. I'm going to change this so that I have a fraction equals a fraction. Now that I have a proportion, I already did step 3. I'm going to crisscross multiply to solve. When I multiply x times the sine of 40 is a number. I like to include parentheses there so that I know that I can't split up the sine and the 40. Sine is an operation, 40 is the argument. They have to go together. You can't just have like multiplication without numbers that you're multiplying, right? You have to have numbers with the arguments. And then 19 times 1 is 19. X times the sine of 40 is equal to 19. Well, we just talked about how the sine of 40 is an actual number. I could plug that in a calculator, and we're going to. But I need to get x by itself. X times the sine of 40. So to move the sine of 40, I'm going to divide by it. I have 19 divided by the sine of 40. Depending on your calculator, you might have to do this in 2 steps. If you have a multi-line calculator or if you're using decimals, you can do it in 1 step. So I'll show you what I mean. 19 divided by the sine of 40. I may have to do the sine of 40, get an answer, and then do 12 divided by this number. That was a great copy and paste, maybe not. Well, on a regular calculator, you would just do sine of 40 and then 12 divided by that answer. Guess I'm not, this doesn't have the same capability. So I'm going to do 12. Nope, the problem was 19. Sorry, scratch some of that. 19 divided by the sine of 40. Your calculator will often prompt you with parentheses. And if I put parentheses around the 40, it's not going to change anything. It's all good. $29.55875. 29.558. I'm just going to record 3 of them. When we go back to the instructions says I'm going to round to the nearest tenth. So I want 1 decimal place, which means I'm going to look at the second decimal place. This is 5 or greater, so I'm going to round to 6. So 29.6 for my answer. All right, and we set up our first problem to solve for a side using trig. Okay, so starting with problem B. Start from your angle theta. So whatever acute angle is identified, that's where I'm going to put my theta. Identify where your missing and known sides are. So what do I know? I have side length 12. Where is 12 located? Is it hypotenuse, opposite, or adjacent? 12 is adjacent. Where is x located? It's the hypotenuse. Now go through your list for SOHCAHTOA and decide which trig function uses adjacent and hypotenuse. Okay. Hopefully you recognize that the A and the H comes from cosine. So the cosine of the angle, which is 46 degrees, is equal to the adjacent divided by the hypotenuse. Check your setup. Does it make sense to you? Next, I'm going to solve. So I'm going to put this over 1 and crisscross multiply. So I have x times the cosine of 46. Now you don't have to put the cosine of 46 in parentheses, but I recommend it. 12 times 1 is 12. I have x times the cosine of 46. I need to get x by itself. The inverse operation is division, so I divide by the cosine of 46. Whatever I do to one side, I have to do to the other. So now I have 12 divided by cosine of 46. So in a calculator, or in decimals, I plug in 12 divided by the cosine 46. Decimals also makes it really nice that you don't have to worry about a lot of parentheses. Some other calculators, you've got to play with your parentheses and really learn those rules, which is great. It's just going to be different for each of you depending on what you're using. 17.274. So I'm just going to record 3 decimal places. That way when I drag it over here, I can narrow it down to the nearest tenth. So I have 17 point, and I want 1 decimal place. I look at the second decimal place, which is 7. I'm just going to round the 2 up to a 3. I don't care about the third decimal place. That 4 isn't going to affect it. Okay? Going back to this problem, the 8 doesn't affect it. Only look at 1 decimal place to the right. Okay, problem C. Going through the same series again. Start from your angle. So where shall I write theta? At 22 degrees. Never at the right angle, always at the given acute angle. If they gave you both angles, you could choose, right? If they'd given me this angle on the right, I could use this angle, all right? I would just choose a different trig function and set up a different equation, which is still correct, all right? For consistency, I'm just saying if they give you one angle, use it. All right, what do I know? I know 10. 10 is which side? The hypotenuse, the opposite, or the adjacent? 10 is the hypotenuse because it is across from this right angle right here. Where is x? The opposite. Which function uses the opposite and the hypotenuse? Sine. So the sine of 22 degrees is equal to the opposite divided by the hypotenuse. Now problem C is a little different than A and B. When I set up A and B, you'll notice that my variable were both in the denominator, right? I had 19 divided by x and then 12 divided by x. This time I have x in the numerator, I have it on top. My steps to solve will be a little different. This is very generic, step 4, right? Solve. Like you have to know how to solve a proportion, whatever that means. So I'm going to put this over 1 and crisscross multiply. When I crisscross multiply here, I have 10 times the sine of 22. And then x times 1. Let me give you a side note over here. It's important that I either write 10 first, or if I write sine of 22 first times 10, that I include parentheses. Watch what happens if I don't include parentheses. I get the sine of 22 times 10, which somebody might mistake by doing 22 times 10, which is not the same thing as 10 times sine of 22. So, way wrong, okay? Have to have those parentheses. Does that make sense? Sine of 22 is a number, all right? I can't mess with the inside of that number. I got to mess with the whole thing. Okay, I'm going to erase all that so that nobody gets confused. It's very important that your coefficient comes first and or that you use parentheses. So this time I don't have to divide by anything. I have 10 times the sine of 22 is equal to x. X is already by itself. So then I just multiplied 10 times the sine of 22. So what does that look like on here? 10 times. Now you'll notice that there isn't a multiplication button because if I just type 10 sine 22, it's automatically multiplication. If you feel more comfortable adding in parentheses, you can certainly do that. Same thing on your calculator. $3.746. 3.7 is one decimal place. I look at the next decimal place. This is not 5 or greater. So I just leave it off and I get x equal to 3.7. Problem D. Going through my steps again. Start from your angle. Here's my given angle, 35 degrees. What do I know? I have side length 17. Where is 17 located? It's adjacent. It's the leg that's adjacent to the angle, right? It's not the hypotenuse. What do I want to know? I want to know x. X is opposite. So identify the trig function that uses the adjacent and the opposite. So the tangent of the angle, make sure you write the actual 35 in there. You can't just write theta. Tangent of 35 is equal to the opposite divided by the adjacent. So we crisscross multiply. 17 times the sine, goofed, times the tangent of 35 is equal to x times 1. I've got another multiplication problem here. Don't need to divide. I just need to do 17 times, and I'm not going to scroll away here. So punch in the 17 times the tangent of 35 on whatever your device is. Okay, when I get 17 times the tangent of 35, 11.903. So when I round to one decimal point, I get 11.9. Now, these problems here don't have any units on them. They could, right? We could include feet or millimeters or something like that, but just be aware that that could be part of the answer. All right. So I've got two more problems here, and I want to ask that you go ahead and try working those out on your own first. Give them a shot. See how far that you can get. Go through these steps. So start from your angle, mark theta, identify what you know and what you don't know, set up an equation and solve. Go ahead and please pause this and try to work out E and F. When you come back, the answers will be here for you to check first to see if you can find any mistakes before I give you the full solution. Hopefully you took that as an opportunity to work these out. Here are the answers. So E is x is equal to 15.9, and for for F, x is the value 8.7. So if you got those, awesome, great job. I'm going to show you the solutions in a minute. If you didn't get those, I urge you to pause this again. See if you can find your mistake before I give you the answers, right? We'll learn from our own mistakes better than watching people just do things right. All right, coming back over to the notebook, here are the solutions for E and F. For E, I identified that I had the adjacent leg and the hypotenuse, which means I needed to use cosine. When I set up my proportion, I have x on the top of the fraction, which meant when I crisscross multiplied, I just had to multiply the 17 and the cosine of 21, rounded to 15.9. Problem F, I recognized 12 as the opposite and x as the adjacent, which means I needed to use tangent. So the tangent of 54 is equal to 12 divided by x. This time x is in the denominator, which means that I'll have to multiply and then divide. So I did that. got 8.718, which simplifies, I'm sorry, rounds is more appropriate to 8.7. Okay, I hope that sits well with you. This is part 2, which comes after learning how to set up the sine, cosine, and tangent functions, and before part 3, where we're actually going to learn how to solve for an angle. So make sure that you're doing those lessons in order. All right, thank you very much, and take care. Bye-bye.